Hello, my name is Sevgi Gurbuz. I'm an assistant professor in the Electrical and Computer Engineering Department of the University of Alabama. I'm thankful to be able to talk to you about my project, which has to do with American Sign Language recognition using RF sensors. A lot of us are probably familiar with the different types of smart environments and assistive devices that nowadays we try to develop for people who are hearing. You've probably heard of things like an Alexa, voice-controlled personal assistants. But how would you use any of those devices if you couldn't really enunciate words carefully, or if you couldn't even hear actually sound? This is a challenge that's faced by many of the people in the deaf and hard of hearing community whose primary language of instruction or communication is American Sign Language. In this project, we're trying to explore the ways of using and developing a new sensing modality, radio frequency sensing, for the purposes of American Sign Language recognition. Many people might feel uncomfortable having a video camera on in their home all the time just for the purposes of using technology. In this project, we're trying to develop radio frequency sensing as an ambient device that would work kind of behind the scenes, but enable people who use ASL as their primary mode of communication to interact with different types of technology. This could be a personal assistant, it could be an assistive robot, or it could be different types of home subsystems. It would operate ambiently in the background. They wouldn't have to change anything that they're doing or change what they're wearing or how they're communicating with each other, but it could offer the potential for the system being able to understand them. In this project, we tried to demonstrate the feasibility of this technology. We were able to show that we could recognize up to 140 different signs using radar sensors. We compared the performance with what we would get with RGB video cameras and found that we got comparable results. The main reason for this is because radar picks up different aspects of the signal than what video picks up. Whereas video picks up all of the visual and spatial variables, radar picks up depth as well as the different velocity components of the signal. Therefore, it gives us a different way of more accurately measuring the temporal cadence of someone signing. Taking advantage of this has been really cool. We've been able to show good results in ambient environments at different distances, different angles, and even when somebody's just going about their own daily business. In other words, we're able to differentiate daily activities from sign language. I'd like to just give a quick shout out to some of our community partners, especially the Alabama Institute of the Deaf and Blind, Gallaudet University, and of course the National Science Foundation for supporting this research. Thank you for listening.